Hey everyone, welcome back to our channel. Ever wondered how we're able to stream, chat, and connect at lightning speeds across the globe? Today, we're diving deep into the glowing world of fiber optics, the unsung hero of our modern telecommunications. Stick around and get ready to be enlightened. Fiber optics, or optical fibers, are long, thin strands of very pure glass, or sometimes plastic, about the diameter of a human hair. They are used to transmit light signals over long distances, and they have become the backbone of modern telecommunication systems due to their high bandwidth and low signal loss compared to traditional metal wires. Here's a basic overview of how fiber optics work. Creation of the optical signal. The process begins with the creation of a light signal. This is typically done using a laser or a light-emitting diode, LED. The light from these sources is then modulated to carry information. Transmission through the fiber. The light signal enters the optical fiber. The core of the fiber, the innermost part, is made of a very clear glass or plastic that has a higher refractive index than the surrounding material, known as the cladding. This difference in refractive index causes the light to be internally reflected within the core, allowing it to travel great distances with minimal loss. Total internal reflection. This is the principle that allows optical fibers to carry light over long distances. When light hits the boundary between the core and the cladding at a certain angle, above the so-called critical angle, it gets completely reflected back into the core. This causes the light to bounce down the fiber in a zigzag pattern or in a helical path, depending on the mode of the light and type of fiber. Types of optical fiber. 1. Single-mode fiber, SMF. This has a very thin core, allowing only one mode or path for the light to travel. 1. This type of fiber can carry signals over much longer distances because there's little interference or signal degradation. 2. Multi-mode fiber, MMF. This has a larger core and can carry multiple modes or paths of light. 2. However, because these different light paths can arrive at the receiver at slightly different times, MMF is used mostly for shorter distances. Receiving the signal. After the light has traveled through the optical fiber, it reaches its destination where a photodetector, like a photodiode, converts the light signal back into an electrical signal. Signal regeneration. Over very long distances, even the minimal loss in an optical fiber can add up, leading to a weakened or distorted signal. To counteract this, repeaters or amplifiers are placed at intervals along the fiber route. These devices boost the signal strength or regenerate the signal to continue its journey. Advantages of fiber optics. 1. High bandwidth. They can carry large amounts of data at high speeds. 2. Low attenuation. Signal loss is much lower than in traditional copper cables. 3. No electromagnetic interference, EMI. Unlike metal wires, optical fibers are immune to EMI, which can be a significant source of data corruption. 4. Security. It's difficult to tap into a fiber optic cable without being detected. Fiber optics have transformed the world of telecommunications and have wide-ranging applications including internet data transmission, telephone, medical imaging, and military communications. That's a wrap on the magic of fiber optics. If you've enjoyed this luminous journey through the backbone of our digital age, don't forget to hit that like button and subscribe for more tech insights. Remember, every time you're streaming your favorite show or making an overseas call, there's a good chance fiber optics are working behind the scenes. Thanks for tuning in, and we'll see you in the next video.